Okay, the second thing we're going to say about linear functions is that a linear function, or a linear relation, we should say, when graphed, can appear in one of three ways. It can appear as a vertical line. You can see this line right here. That's a vertical line. It can appear as a horizontal line. This one's horizontal. Or it can appear as a diagonal line. Now, as a diagonal line, it can either go up and to the right, or it can go down and to the right. Okay, and so to understand this, or at least to be able to graph them, the vertical line, when it always takes on the form that looks like this. It's always x equals to some number that we're going to refer to as b. And so, for example, this graph, you can see that it's a vertical line at 1, 2, 3. And so this is the line x equals 3. Okay? So if you just do x equals a number, you'll get a vertical line on the graph. Okay? And in this case, every point on the vertical line is going to it's going to take this form. It's going to be the point b, comma, y, some number. So it's going to be the same number, in whatever b is, comma, some y value. So for example, this point right here, that's the point 3, comma, 4. This point right here is the point 3, 2. Okay? This point right here is the point 3, negative 1. Every point, this point is 3, negative 5. Every point on a vertical line has the same x value, and then it just has different y values. A horizontal line is very similar, only instead of x equals, it's going to be y equals. Okay? So it'll be y equals some number b. Okay? In this case, it's y equals negative 2. Okay? You can see right here, this is the horizontal line at y equals negative 2, so this is y equals negative 2. And so all horizontal lines will take on the form y equals b, with every single point, being some number x, comma, that number b. Okay? And so like this point right here is the point negative 3, comma, negative 2. This point right here is the point 2, negative 2, and this point over here is 5, negative 2. But in every case, the y value is negative 2 because y is equal to negative 2. It defines the line. Okay? And then diagonal lines. So diagonal lines, they can either go right here. This one right here is up and right. Okay, so a diagonal line can go up and right, or this one right here goes down and right. It starts here, it goes down, and then to the right. Okay, so it goes down and right. Now, an up and right line we call positive, and a down and right line we call negative. Negative. And a diagonal line takes on a form that we'll describe more later. It takes on the form y equals mx plus b. And you'll notice that the diagonal line, the vertical line only has x in it. The horizontal line only has y in it. Well, a diagonal line is a little vertical and a little horizontal, right? It goes up and right, okay, or down and right, and therefore it has both y and x in it, okay? It's a relationship between x and y. And this form is called the slope-intercept form, y equals mx plus b, but you can also define it in terms of x, and when you define it in terms of x, it winds up being y minus b divided by m, okay? One other thing I want to say is when it's up and right, this m right here, this is called the slope. That's what we're going to talk about in just a minute. For a positive up and right, the m is always greater than 0. And for a negative, the m value is always less than 0, which is a negative number, and that's why we call it negative.